All right, what is up, everybody? So in today's lesson, we're going to be looking at multiplying and dividing rational expressions. So let's jump into it. Here's the main idea, guys. If we have a factor that's in the numerator and the denominator of an expression, then we can cancel that out. So let's just jump right into an example. What we do with this one, and there's really two rules, guys, for these problems. Number one, you want to factor everything you can factor. And then number two, look for things that you can cancel. So with this first problem here, we could factor the numerator to get x plus 4. I guess let's see. Let's do plus 2. And then x minus 6. All right, so 2 times negative 6 is that negative 12, and then 2 plus the negative 6 gives us the negative 4 there. All right, and then let's divide by this. So let's factor that as well. This is a difference in squares. So remember, with a difference of squares, we can take square root of the first plus square root of the second. Square root of 4 is 2. Times square root of the first minus square root of the second. And we can see now we factored everything here. And at this point, we can see we have an x plus 2 and an x plus 2 in here. So since we have the same factor in the numerator and denominator, we can cancel those out. And our answer is just going to be x minus 6 over x minus 2. And that's it. That's your answer. Nothing else can cancel out. Now, when it comes to multiplying, it's really pretty straightforward. All you're doing is taking the numerators and multiplying those across, and taking the denominators and multiplying those across. So really what you're doing is you're just combining the two, and you can almost treat this as one factor and this as another factor. But let's multiply these and see what we get here. So you can multiply the big numbers. 8 times 7, or the coefficients, I guess is what we call them. We can multiply 8 times 7 to get 56. Okay, and then with the exponents, remember when you multiply x's, you add the exponents. So x cubed times x to the 4th will give us x to the 7th. Y times y cubed will give us y to the 4th. Okay, now let's multiply the denominators. 2 times 4 is 8. X times, there's not another x, so we'll just have an x. Y squared times y will give you y cubed. Now again, look for things that you can cancel. We know that 56 divided by 8 is 7. X to the 7th over x, one of those x's can cancel, so we'll just be left with x to the 6th on top. We have 4 y's and 3 y's down here, so 3 of those y's can cancel, so we'll just be left with 1 y in the top. And then that's it. So since everything's in the numerator, this right here is our answer. All right. Okay, here comes another one. For this one, let's factor everything we can factor. Again, remember that we're multiplying across, so we can kind of combine them into one. So let's do that, but let's factor everything. So we can pull out a 3x out of both of these terms. So we'll have a 3x times 1 minus x, if we pull a 3x out of both of these terms. And let's go ahead and draw our line here. Let's factor this as well. Again, remember, we can just kind of combine the two across. So x squared plus x minus 20, let's factor that. So we'll have an x and an x. This is a minus sign right here, so we'll have a plus and a minus. What times what equals 20? 5 times 4 is what I'm thinking. So 5 times 4, and we see a 5 plus negative 4 gives us 1, which matches that middle term. Okay, let's factor the bottom now. Same thing with this one. Let's factor this. So we'll have x and an x. This is a minus, so we'll have opposite signs. And the only thing we can factor 5 in is 5 and 1. So let's do that. 5 times 1. And 5 plus negative 1 it does give us that 4. And then we also have this 3x. All right, look for what you can cancel. We can cancel that 3x. We can cancel the 5 or the x plus 5. Now look at these two. They almost look like we can cancel them. The only difference is this one has opposite signs of this one. This one is negative x, this is positive x, this is positive 1, this is negative 1. So what we can do here is we could replace this 1 minus x with a x minus 1 times negative 1. Because the negative 1 times this would get us back to here. And then we can cancel the x minus 1 and the x minus 1. So all we're left with is stuff in the numerator, which is negative 1 times x minus 4, which if we do that, negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. So there you go. All right, so again, if you have two factors and the only difference between them is a factor of negative 1, just pull that factor of negative 1 out and then you can cancel the two. Okay, this one is very similar. Would y'all agree that x squared plus 3x plus 9 is the same thing as all of that over 1? So then you can just multiply it the same way. So let's factor everything. X plus 2 is just going to be x plus 2. This numerator up here, we can't factor. If you try, you're just going to get a headache because 3 times 3 gives us 9, but 3 plus 3 does not give us 3. 9 times 1 gives us 9, but 9 plus 1 gives us 10, not 3. So it doesn't matter what you do, you're not going to be able to factor that, so just leave it the way it is. And then in the denominator, we have this x cubed minus 27. So remember when you factor a difference in cubes, you could go back a few chapters ago to when we did this, but there's a pattern for it. Remember, it's I think it's a minus b. Let me make sure that I am telling you correctly. Yeah, it's x minus 3. Or it's a minus b times a squared, which is x squared, plus ab, which is plus 3x, plus b squared, which would be 9. And we can see now that we have the same thing, x squared plus 3x plus 9 in numerator and denominator, so we can cancel those, and we'll be left with just x plus 2. Oh, and I realize you can't see that. I'll write it down here. We'll be left with x plus 2 over x minus 3. And there's your answer. Okay. All right. Moving on to division. You may remember this when you're dividing fractions. We can turn this into a multiplication problem. All we have to do is just flip the second fraction. So we could rewrite this as 7x over 2x minus 10 times x squared minus 11x plus 30 over x squared minus 6x. And then we just treat this the same way as all the rest of them, so we can factor this. So let's factor that numerator first. So we'll just have a 7x, and then we can factor the x squared minus 11x plus 30. So we'll have an x and an x. It's a plus sign, so they'll both be the same as this one. 6 times 5 gives us 30, and -6 plus -5 gives us that -11, so that works out. Right, and then in the denominator, we can take out an x out of both of these. So we'll have an x. I guess let's do that first. For this first one, we could take a 2 out. So we'll have 2x minus 5. And then let's factor this as well. We can bring out a x, it looks like. So we'll have just x minus 6. And then look at what you can cancel. You can cancel this x right here with this x minus 6, and x minus 5. So all you're left with is just 7 over 2. And that's it. Okay, one more. Same idea here. This is the same thing as all this over 1. So if we switch this to multiplication, we just flip these two. So we'll have 6x squared plus x minus 15 all over 4x squared times, we'll flip these, so it'll be a 1 on top and 3x squared plus 5x in the denominator. Okay, let's factor. So let's factor this first thing first. And let's see what we can get out of this. This one's going to be kind of a booger, but we'll try it out anyway. Let's see, what times what? 2 times 3, so maybe 2x and 3x. This is a minus, so we'll have opposite signs. What times what gives you 15? 3 and 5. I think 3 and 5. So let's multiply them. 2 times 5 gives you -10. 3 times 3 gives you +9. So we'll have -1. So we just need to switch our signs. So we'll have a minus here and a plus here. Is that right? Let's try this again. -3 times -3 is -9. 2 times 5 is 10. 10 plus -9 is 1. Good. All right, so that worked out. Now let's factor the bottom. So we got a 4x squared. And then for this term right here, we can bring out an x, it looks like. So we'll have an x times 3x plus 5. All right, so what can we cancel? We can cancel the 3x plus 5. And what we'll have left is 2x minus 3 all over 4x. And it looks like that's 3 x's in all, so x cubed. Now let me double check this and make sure that this is right, because it feels a little weird. 2x minus 3 over 4x cubed, we got it right. Let's go. So that right there is our simplified quotient. Okay, same idea though, guys. Every single time, what you're doing is just factoring top and bottom, and then trying to see if you can cancel anything out. But I'm going to end the video there, guys. If you have any questions, let me know, and I'll see you next time.